The flat Earth is an endless plane or a plane that goes on for an incredible amount of distance. It's frozen and parked in a circular orbit of around a magnetic center is a capacitor. We'll call that the sun. So you're looking at this picture here. This is just like a puddle in the ice sheet, and the sun rotates around the center, and that creates the world that we know. Antarctica is not a continent on the bottom of a ball, but rather the ring that surrounds the planet. Next slide, please. The next slide, people ask, how do you circumnavigate people have circumnavigated the globe. Well, if you go west, you will go keeping north, the magnetic north to your right, equidistant, you'll just make a big flat circle. Next slide. And then if you go east, in the other direction, same thing. North is always to your center. The inner northern hemisphere is the center, and the outer southern hemisphere is the southern part of the world. Next, if you go any direction away from north, you're going south. You'll hit the ice wall, and if you are able to get over it without one of the 40 nations that have a treaty that won't allow you to go there, you'll just keep continuing over the ice sheet and never return. Next, these three lines here, the red is the equator, the orange is the Tropic of Cancer, and the yellow is the Tropic of Capricorn. The sun circles around, making tighter circles in our summer, and then it goes to the yellow line in Australia's summer, making faster, wider circles. Continue to the next. Here is a picture of Australia's summer, our winter. This is December 21st. The sun is making the big outer loop. Next. And then the next one is the northern inner hemisphere's summer, June 21st. It's nice and tight. We have some very long days, midnight sun in the North Pole, which we'll get to soon. Next. This is just an illustration of the sun. Is lighting up part of the world. Everybody says, well, it would be light all the time, on the Earth. Well, that's because we believe that sunlight will travel for billions and trillions of miles, but that's not true at all. It goes a very short distance before it peters out, the wavelengths separate, the colors change, and it disappears. So this is a rough illustration of that. Next, this is just an illustration of, next slide. There you go. Is an illustration of how a ship would go around the world. It's like walking around your neighborhood. You're not going around a sphere. You're making a big flat, circle, or as close to a circle as you can get. Next, if you go south, you'll eventually hit the Antarctic ice wall, which surrounds the entire flat Earth. Next, this is the ice sheet. South is across the top of that sheet, and it just keeps on going and going and going. Next, you can consider go back one. You can consider this the meniscus of the melted puddle that holds all of the water in. Now we go to the next one. We've had one shot of the Earth, I think, since 1970 something or whatever the Apollo shot was, and then we recently got this new shot of the Earth, the big blue marble. It's on every iPhone. It's in every movie. And this was taken with NASA's new camera. Go ahead, next slide, called the DSCVR, and it's taken by the Earth Polychromatic Imaging Camera, the EPIC. And if you put that together, they're laughing in our faces. It's the EPIC Deceiver. Next. If you take a look at the picture that they're showing us, you'll see, if you zoom in, that it's a complete Photoshop, not even Photoshopped, it's a painting. And they used, to put the clouds in, they used Photoshop, and they stepped and repeated. They're very lazy at NASA. I guess they don't know what to do with all the trillions of dollars they stole from us, and they hire really crappy graphic artists. Next, every picture we've seen of a planet, these are two pictures of Earth from NASA. I think they're like 30 years apart or whenever they were taken, and they can't even get the proportions right on the planets. This is supposedly a picture of the Earth from space, and the United States is twice the size in one. Next. Every picture we have from NASA of a planet is a artist rendering. They're not real pictures. If you take a strong telescope and look at a planet, it looks nothing like this. It looks like a self-illuminating light. It looks more like a star. They used to call planets wandering stars. Next, Saturn, I've looked at myself through high-power telescopes, and it really looks like a light bulb. It doesn't look like it's reflecting light. The rings are lit up. There's none of these colors on there. And these are just artist renderings. And if you believe that they're real, you're just sadly mistaken. Next, we recently had Pluto, pictures of Pluto, the one kind of center bottom is the most recent one, and that was taken by a probe that was whizzing by Pluto. Pluto's spinning, there's barely any light out there, and it gets this perfect, brightly lit, crisp, clear image of Pluto and transmits it all the way back to Earth, where we can barely get cell phone signals, when you go out of town. Go to the next one. And if you look at it, again, Disney style, they show us this ridiculous picture, and Pluto is actually on the moon. I mean, on Pluto. They're literally laughing at us. Next, a lot of ball earthers say that the eclipse of the moon proves that the Earth is round because it's a curved shadow. To me, that doesn't look like much of a curved shadow. There's been many documented eclipses where the sun and the moon are above the horizon during the eclipse. The moon is self-illuminating, and it is not a big rock up in space. As a matter of fact, it's transparent. Next, if you look at this shot at night, the craters, or the dark spots, I like to call them, are black because it's in our sky and there's black sky behind it. Next, if you look at the full moon during the day, those spots are now blue because we are seeing through whatever the moon is. And to prove that, go to the next one. We have a crescent moon, and behind the moon was a planet. And when you zoom in, you can see the planet through the moon. And this shot was proven that there was a planet in that position, and you could see it behind the moon. And there's many people that have photographed this many times. Next, one of the first things that woke me up to the flat Earth was that no matter where you are, at sea level, at the top of Mount Everest, top of a building, or in an airplane, the horizon is always at eye level. It's always at eye level. And on a ball Earth, like on the left, as you rise up, the horizon should drop off, but that's not what we see. We always see the horizon at eye level. Next, here's a little exaggerated picture of what it looks like from an airplane. The horizon not only should drop off in front of you, but it should drop off more visibly to the left and to the right. And the equation for that is 8 inches per mile squared. So as you get up over 100 miles, the drop is drastic. Next. This is a shot from 20 miles up from a hot air balloon, or a helium balloon. The horizon is flat. And Google Earth says at the same height, this is what the Earth looks like. And they're just faking it. That's not what the Earth looks like, because there's a picture of what the Earth looks like. Next, here's a shot of Dubai. I believe it's Dubai. If you look in the horizon is at eye level from the elevation that they're at, and it is flat. Next, another shot showing just a straight flat horizon. Next, this is what this is a shot that they'll show us just from a tower. This is not even, this is obviously a fisheye lens, which bends the Earth. If the Earth had this kind of curve to it, it would be very, very small. Next. Here's a shot. I believe it's the top of Mount Everest, flat horizon once again. And look at that sun. Does that look 93 million miles away? That sun is close. It's within our sky, and we'll get more into that in a moment. But some people will look at this picture, they'll put a straight edge on it, and they'll say, look, it's a little bowing out, and it looks like a circle, but again, it's a flat circle. Next picture. This is my dining room table. It is not a ball. It's a flat circle. And that's how we see. We see the same distance to the vanishing point in all directions. So when you look to the left at 9 o'clock, you see X distance to 10, 11, 12, 1, 2, 3, X distance. You draw a line, connect all those distances. You're drawing a big flat circle, and that's what you're seeing. But our programming tells us it's a ball. Next. Here's just a few more shots. We have a balloon. Again, look how close the sun looks. Cruising altitude about 5 miles up, sea level, flat, straight horizon. Next. Here's a shot with a level, and you're looking across the level. Your eyes are level with the level, and there is the water. Straight, does not bear off, does not fold over backwards. Water is level. Next. Again, another shot, impossible if the Earth is a ball. Continue. Here is the famous Felix Baumgarten Red Bull jump, and everyone uses this as proof that it's a ball. When he opened the door and you looked out, there was a straight shot across. It was only a little bit of the horizon, but it did not look curved like this. But if you can argue that all day because it was only a little bit, and some people might say there's a curve. But below him is New Mexico. Last time I looked, New Mexico did not cover a third of the planet. This is a low altitude shot with a fisheye lens. Next. This is a shot from the dog cam, which is 110,000 feet, just slightly lower than the Felix's shot. And again, the horizon is flat, straight, and the sun is very close. Next, here again, check out the sun. The sun is very close within our sky, and notice the hot spot, the reflection on the Earth. Straight horizon. Next. We'll talk about the vanishing point a little bit. These lines are parallel the way we see. They don't look parallel here, but if you flick to the next one, these are the corners of the hallway, and they rush to the point of convergence or the vanishing point. And that's how our eyes see. Everything rushes in from the sides, the top and the bottom, to our point of focus. And that's the vanishing point. The sky has no bumps on it. The sky is smooth, but the earth has bumps on it. It has mountains, it has trees, it has cars, people, waves. Anything that comes across the flat plane that even rises up a little bit will create a false horizon in front of that vanishing point. So if you look at the light on the ceiling and imagine that's the sun, the sun's not getting any closer to the floor, but it is going down. And if you had some bumps in the hallway or some people standing down the hallway, the sun would disappear. That light would disappear behind their heads from the bottom up, just like we observe on this plane. Next, here's just a shot across the flat plane, how everything goes to the convergence point. Next, here's a shot, a slide I made, where the point of convergence, the vanishing point, is behind that mountain, and that mountain is creating a false horizon. So as the sun moves into the distance, it gets smaller and smaller, remaining the same height above the flat plane, and then it disappears from the bottom up as it disappears behind the false horizon. Next, this is an experiment that was done years